Hello. This video presentation is our last video presentation about graphing radical functions. Kind of go over what we did the last 2 days. What we ended up doing is looking for numbers for x such that x plus 4 equaled 0. That's when x is negative 4 right here. X plus 4 equals 1, that's a crappy looking 4, which is x equals negative 3, which is right here. And then we looked for x plus 4 equaling 4, x is 0, x plus 4 equals 9, x equals 5, and x plus 4 equals 16. We're off my graph. X plus 4 equals 16. That would have been 12 and off my graph. And we want these numbers to equal 0, 1, 4, 9, 16 because we can take the square root of 0, 1, 4, 9, and 16. Now, it's going to be a little more complicated today because the radicand is going to have a multiplier. But it's the same idea. We want 2x plus 4 to equal 0. X, if you solve this, would be negative 2. So if I put in negative 2, I get 0. 0 plus 1 is 1, so at negative 2, I'm right there. Now, I'm going to go up 1 each time, so now we just have to figure out what x is. 2x plus 4 equals 1, subtract 4, 2x equals 3, divide by 2. So, negative 3, I'm sorry. So at negative 1.5, this is right there, I'm at 2. And then I want 2x plus 4 to equal 4. X, when we solve this, is equal to 0. So now I'm right here. So instead of going over 1 and going over 4, I'm going over a half and 2. I'm only going half as far. Let's see if that plays out again. 2x plus 4 equals 9. Let's go to the other side. 2x plus 4 equals 9. Subtract 4. 2x equals 5. Divide by 2. So I'm at 2.5. 1, 2.5. So I've gone over 1, 2, 3, 4.5 instead of going over 9. Half of 9 is 4.5. So I'm only going over half as far each time. And lastly, because we can, 2x plus 4 equals 16, 2x equals 12, x is 6, so 3, 4, 5, and 6, my graph looks like that. A clearly defined starting point and an arrow. Now, do you need to show this work? No. If we're going, its multiplier is 2, we go twice as fast through here. Instead of 1, we do a half. Instead of 4, we go over 2. Instead of 9, we go over 4.5. Instead of 16, we go over 8, and so on. All right, last example. Now it's going to be a little trickier. We're going to go down. Because this is negative, we're going to go left. And we're going to be multiplied by 2. So just like before, 1 minus a half x has to equal 0. So add a half x, 1 equals 1 half x. Kill the fraction, x is equal to 2. So we're at 2, 3. 1, 2, 1, 2, 3, and I'm right there. Now, I want it to equal 1. 1 minus 1 half equals 1. Subtract x, 1 half x. I subtract 1, I get minus a half x equals 0. Kill the fraction, x is 0. So now, at x equals 0, instead of going down 1, I go down 2. So instead of going over 1, now I doubled it because my multiplier is a half. Let's do one more and see if this works out. So 1 minus a half x now has to equal 1. I already did that. Now it has to equal 4. Subtract 1. I get negative a half x equals 3. Kill the fraction. X is equal to negative 6. So 1, 2, 3, 4, 5, 6. And I'm right here. Normally I go over 1. Now I went over 2. Then I go over 4. I went over 1, 2, 3, 4, 5, 6, 7, 8. Then I go over 9. I would go over 18. I'm going to be off the graph. My graph looks like... try that again. My graph looks like this. I continue to go down. Clearly defines starting point and an arrow signaling I go the other way. All right, that's it. That's the last video before we come back for a break. And have a great day. Talk to you guys later.